In 2017, residents of Yellowstone National Park in the United States noticed something very strange. Strange enough to make them take out their phones and start recording. A large gash had suddenly appeared in the ground and steam was pouring out of it. It looked like the earth itself was vomiting out huge amounts of vapor. And the fact that it happened so fast was what made it so weird. It's not uncommon for geysers to appear in Yellowstone National Park. They even have a name for it there, a term coined by the indigenous people of the area who called the park the land that is boiling. Around 10,000 years ago, a supervolcano erupted here. This eruption was so powerful that it changed the course of human history. It wiped out most of the megafauna on the North American continent and also led to an ice age. But the magma chamber beneath it is still active. The eruptions here are regular, but usually not spectacular. That is until now. The locals captured the moment when this new vent opened up and posted the videos online. They were surprised that nobody seemed to know anything about it, or that the authorities had no idea it was going to happen. So they decided to take matters into their own hands. An amateur geologist named Jake Hart wrote an article about it and sent it to various media outlets. Then the mainstream media picked it up and started broadcasting it all over the world. Everyone was talking about this amazing natural wonder, but Jake kept insisting it was a man-made construction. His theory was that the government had secretly been digging a tunnel underneath the volcano, and that it had collapsed, creating the giant vent we see today. If he was right, then we would be looking at the first ever tunnel to penetrate a magma chamber. But is that really what happened? How could someone even dig such a tunnel? And what do we actually know about the magma chambers beneath supervolcanoes? We thought these questions might be on your mind. So let's get started with answering them. When the locals first saw this, they thought it looked like this. The water was boiling, so much so that it was producing huge amounts of steam. You can see how people could easily jump to the conclusion that it was some kind of man-made steam vent, especially because of its shape. It's not like this in any other geyser in the park, but this is where Jake's theory diverged from reality. When scientists arrived at the site, they collected samples and studied the chemistry of the vapor. They found out that there was too much silica in it, which meant that it wasn't coming from a magma chamber. In other words, it wasn't produced by a reaction between rock and molten magma. Instead, it was most likely created by water that had percolated down through the layers of ash left behind by the volcano after the big explosion. But if it wasn't coming from the magma chamber, why did it look so different from the other geysers? Well, it turns out that before this eruption, there was a smaller one that created a crater nearby. The opening of this crater was clogged with rocks and minerals, so the steam couldn't escape. Eventually, the pressure got too high and blew the rocks off the top, creating the enormous outburst of steam we see today. It wasn't man-made, just incredibly rare. But we can understand why people would assume that this was evidence of a secret government project. After all, in the past, underground cavities have been used to store things like nuclear waste or natural gas. In fact, there's even a place in Germany where people have put unwanted stuff since World War II. It's become known as the Gallup's Corner, and it holds everything from old shoes to weapons and ammunition. This raised the question of whether the government might be doing something similar in Yellowstone National Park. There's already a lot of conspiracy theories surrounding what the government does at Area 51 and other top-secret military facilities. So it isn't surprising that people want to know more about what goes on in Yellowstone too. But there's a problem with trying to find the answers. We still don't know exactly what's inside a magma chamber. By studying volcanoes, geologists have learned quite a lot about how they work. They know that magma chambers come in all shapes and sizes, and that they can form in different ways. Some magma chambers form when magma pushes up against the roof of an underground cavern and creates a dome-shaped pocket. Others form when two tectonic plates collide and force magma to rise up and pool in a magma reservoir. Geologists also know that magma chambers aren't just hot, molten lakes of lava. Most of the magma in a magma chamber is actually solid rock. The only difference between magma and regular rock is temperature. If it's below 1000 degrees Celsius, it's called rock. And if it's above that, it's called magma. So a magma chamber is really just a giant batch of partially molten rock. But even though geologists know a lot about magma chambers, they still don't know exactly how they work. One reason for this is that they can't study them while they're active. The only way to collect data from a magma chamber is to drill a hole into it. But obviously that's impossible when it's actively producing volcanic eruptions, and drilling into an active volcano seems like a bad idea. So instead, geologists have to rely on computer models to try to figure out how magma chambers work. These models are based on equations that describe the physical and chemical properties of magma chambers. But because we don't know all of those properties, the models are only approximations. For example, we don't know exactly how the rock in a magma chamber behaves when it's under high pressure or how the magma mixes with the surrounding rock. So the models have to make assumptions about these things. And since the models are only approximations, they can't tell us exactly what a magma chamber looks like. What we do know is that the roofs of magma chambers are typically very strong, stronger than steel, in fact. This is because the weight of the magma chamber squeezes the rock until it hardens into a solid mass known as a sill. So, if anyone was going to try to tunnel under a magma chamber, they would have to go through that sill. And once they got through it, they would find that the magma chamber is mostly solid rock. The only liquid magma will be found in small pockets or veins throughout the chamber. So it wouldn't be possible to dig a tunnel without running into these pockets of liquid magma. Now, magma isn't like quicksand, so you won't be melted down if you touch it, but you would certainly get burned, and that's assuming that the magma wasn't so hot that it just instantly turned your drill into slag. Another problem is that the temperatures in magma chambers vary. The deeper you go, the hotter it gets. At the center of a magma chamber, temperatures can reach 1300 degrees Celsius. That's why the government doesn't need to blow up a mountain to access a magma chamber. All they have to do is dig deep enough. The heat emanating from the magma chamber will melt through the remaining rock and turn the tunnel into another opening for the magma chamber. So unless the government wants to accidentally create a new volcanic eruption, they won't try to dig a tunnel through a magma chamber. What about the vent that appeared in Yellowstone National Park? We know that it wasn't caused by a secret government project. It's most likely that the opening of the crater became clogged with rocks and minerals so the steam couldn't escape. Eventually, the pressure got too high and blew the rocks off the top, creating the enormous outburst of steam we see today. If this is true, then it means that we may never know exactly what's going on inside a magma chamber. It might not be possible to study them while they're active. We can learn more about how volcanoes work by studying the rocks and minerals that are ejected during an eruption, but that only tells us so much. So for now, we'll just have to settle for the fact that we don't know exactly what's going on inside a magma chamber. Now you need to watch. Why did the Roman Empire fall? Or have a look at